Hello students, in this lecture we will solve problem based on trigonometric, logarithmic and exponential functions. We have derived relations of trigonometric, logarithmic, exponential function in previous lectures. Now we will solve problem based on them. Evaluate the limit x approaches to 0, sine 2x plus sine 6x upon sine 5x minus sine 3x. So by taking left hand side, now we'll convert this trigonometric sine into sine limit x is 0 or sine x upon x is equal to this form, and the limit of this will equal to 1. So for that we have taken the left hand side and divide the numerator by 1 by x, divide numerator by 1 by x and denominator by 1 by x. If we reciprocate them, then they will cancel out, and to adjust them here, I think this function, the, after this multiplication by 1 by x and numerator denominator, function remain the same, and it will help us in evaluating this limit. So now this is sine 2x upon, this will become sine 2x upon x, sine 6 upon x, sine 5x upon x, and sine 3x upon x. Now again, in order to convert the sin x upon x, we multiply this by 2, limit sum of the limits, and the quotient using the algebra of limits, limit of quotient limits, and limit of sum of the, and limit of difference of limits. We will get, we multiply this numerator and denominator sin x 2x by 2 by 2 and divide by 2. Similarly, sin 6 by x we divide multiply 6 and divide by 6 to make this equal, to make make this thing equal, sin 2x upon 2x, x and sin 6x upon 6x, and sin 5x upon 5x, and sin 3x upon 3x. Now limit x approaches to 0 of sin 2x upon 2x plus sin 6 into limit x is 0 sin 6 upon 6x upon 5 limit x is 0 of sin 5x upon 5x minus 3 limit x is 0 of sin 3x upon 3x. Now as now this 2x, this is x, this is 6x, this is x, this is 5x, this is x, this is 3x, this is x. So as x was 0, if you multiply very small number by any finite number, very small number will remain very small. Therefore, if x was 0, then 2x will also approach 0, 6x will also approach 0, 5x will also approach 0, and 3x will approach 0. So replace in the first relation x by 2x, and inside this thing x by 6x, in the third this x by 5x, and this is x by 3x. Now this will become formula, limit x, if you put 2x is equal to y, limit y to 0, as 2x to 0, y equals to 0, limit y to 0 of sin y upon y, or similarly they are same, or straight away we can add limit x 2x to 0 of sin 2x upon 2x is equal to 1, in the 6 of 0 sin 6 upon 6x is equal to 1, and similarly this is equal to 1 and this is equal to 1. Substituting their values, you get 2 plus 6 upon 5 minus 3, limit is equal to 4. Answer is. Now let's solve, and then let us solve another problem. Limit x is 0 of x cube cot of x upon 1 minus cos x. Now we have formula tangent x upon x, and limit x is 0 of tangent x upon x equal to 1, and limit x approaches to 0 sin x upon x equal to 1. So we'll convert them into tan and sin. So if you take cot x is equal to 1 upon tangent x, so this cot x is 1 by tangent x. 1 minus cos x will be converted into 1 minus sin square x, by 2, cos 1 minus cos x equal to 1 2 sin square x by 2. So similarly, now divide numerator by x and denominator by x. X cancels out, this is x square, tangent x upon x. Now x will, now we are converting into formula. we are doing all this to convert into formula sin x upon x or tan x upon x. So limit of the, now this x upon 1, if you take this denominator, this will 2 sin square x by 2 upon x square. Now we have to make this same again, same again. We multiply it by this square. We take it inside the bracket, x square. Now multiply by 2, divide by 2. This, if 2 will be taken out, this will square of 2, 4. 4 will be 2 cancel, and 2 will go to the, this 2, this 2 will go to the numerator. Outside 2 is here. Now limit of the product limits, limit of tangent is 1. Limit of this will equal to limit x approaches to 0 of sin x sin x by 2 upon 2 sin x by 2. 2 was taken common, so this will become limit as x equals 0, x by 2 also equals 0. So limit x by 2 equals 0 of sine of x by 2 upon x by 2. This will become 1 whole square, and this 1 by 2 will go to the numerator. 2 upon 1 into 1 is equal to 2. So that limit x approaches to pi by 2, secant x minus tangent x upon pi by 2 minus x is equal to half. So x as, now let's take the limit to x equals 0. As x approaches to pi by, x approaches to pi by 2, that is x is equal to x approaches to pi by 2 plus h. So as x approaches to pi by 2, h is equal to 0, h is equal to 0 for positive from positive. So make a substitution here. Limit x to 0, secant of x approaches pi by 2 plus h plus minus tangent of pi by 2 plus h. And this will cancel out, pi by 2 cancel out, this will minus h. Now convert them into, because we know formula sine and cos, you convert into sine and cos. 1 upon sine, this is 1 upon sine, but minus sine, minus minus numerator, but minus numerator, this will go to numerator, this plus, this minus, this plus, this plus, this minus. And now LCM 1 upon h. LCM is sin x, this is 1 minus cos x by sin x, limit x upon x, limit x is 0. Now 1 minus cos h is equal to 2 sin square x by 2 upon sin h is equal to 2 sin h by 2 cos h by 2. 2 cancels, sin h by 2, sin h by 2 cancel. This will be left with sin h by 2, sin h by 2, limit is 0. This is half. This is equal to sin h by 2 upon cos by 2, and 1 upon h multiplied by half, to make the same. 1 by 2 is outside. As h is 0, h by 2 also equals 0. So this will become 1, and limit x is 0 of cos by 2 is equal to 1. So limit this to 1, half of 1 into 1 by 1 is equal to 1 by 1. Now again, evaluate the limit h approaches to x approaches to pi by 4 from positive of greatest integer function sin x. Now we can solve this problem in 2 ways. If let fx equal sin x and gx is equal to greatest integer function, greatest integer function less than equal to x. Now domain of sin x is equal to all real number, range is from -1 to 1, closed interval, and gx is domain is all real number and range is set of integers. Therefore, uh, a range of sin x is the subset of domain of this function x. This is so this. Therefore, g of f is defined. Defined as x is pi by 2 from positive, sin x is increasing from 0 by 2. So now we have to convert the limit. So when x approaches pi by 2 positive means x is greater than pi by 2, therefore pi by 4 implies sin x is greater than pi by 4. Sin x is slightly greater than sin pi by 4. Sin x will equal to sin x pi by 4 means sin x will equal to slightly greater than means as x approaches to pi by 4 from positive, then sin of x will equal to 1 by 2 from positive. Now limit f of x. Limit x is to pi by 4 positive of f x equal to limit x is to pi by 4. Limit x is pi by 4. Pi by pi over 4 of pi over 4 of sine of x is equal to what, 1 by root 2 because so now the limit in place of now here is y, we put this equal to y, so limit y approaches to, or we can write sine of x approaches to pi over 1 by root 2 from positive, or we can write y equal positive sine here. So which to 1 by root 2 for positive of y is equal to this is function of root 1 by root 2 and root 2. This will be multiplied by root 2 divided by root 2. And root 1.7 is value. This comes to be gets into function of 0.70 is equal to 0. Evaluate the limit x approaches to pi by 2 of 1 minus cos x upon 1 plus cos x. So if we substitute x to pi by 2, this becomes 0, this becomes 0, and straight away we'll get the limit because this is a continuous function, limit is equal to 1. So not interpreted for the limit. Now evaluate the limit x approaches to 0 of sine of 2 minus x minus sine of 2 plus x upon x. So sine, now if x is 0, 0, sine 2 minus sine 2 upon 0, 0 from 0, written form. So in order to solve, we have to apply formula. So we are applying quadratic formula sin c minus sin d. Sin c minus sin 2 cos c plus 2 sin c minus 2. So substituting in the numerator here is we got 2 cos 2 plus 2 by 2, this minus this by 2, cos c minus d by 2. C minus d by 2, c minus d by 2, this minus is equal to c minus d by 2. So this will be minus here, minus x, minus x. So this is equal to sin of minus x is equal to minus sin x, minus sin x. So cos of 2, limit x is 0, sin x is equal to 1. So this answer is minus 2 cos of x. Cos of x is the answer. This minus this by 2. C minus d by 2. So minus d to cancel, this one is right. This is the answer. Now evaluate the limit x equals to a tangent x minus tangent a upon x minus a. If we place x by a, this will 0 by 0 form. Now we want to convert it into sine and cos forms. So convert it into sine cos, take the LCM, simplify them, and we got sine a cos b cos a sine b, sine of a minus b upon cos x cos a, cos x cos a into 1 into 1 upon x minus a. So now the limit of this as x goes to, if we change the limit, this value is equal to 1, and limit of x which is to a cos a cos a cos a, this is 1 for cos a, this is cos a, x is to a cos of x is equal to cos a square, and limit is equal to 1, is equal to 1 upon cos a square, and so secant square is the answer. Now limit x which is to a of sine x minus a upon x minus a is equal to, then make a substitution x is equal to a plus x, as x is equal to a positive x equal to 0 from positive always. Limit x is 0 of sine of a plus substitute x by a plus x minus a plus a minus a. So we cancel out sine of limit x 0 of sine x upon x equal to 1. Yeah, substitute here. So limit is equal to 1. So we can this limit. Next question is, show that limit x is to pi by 4 of 1 minus tangent x upon x minus pi by 4 is equal to minus 2. Taking left hand side, limit x is to pi by 4 of 1 minus tangent x upon pi by 4 x minus pi by 4. So as x approaches to pi by 4, positive is not enough, from positive plus h, this is as x to pi by positive, h is 0 from positive always. So substitution, change the limit x is 0 of 1 minus tangent of pi by 4 plus h upon pi by 4 plus h minus pi by 4 cancel. So we have got tangent of a plus b equal to tangent a tangent b and differential v upon 1 minus tan v upon h 1 minus. Now simplifying it, or simplifying, we got tan by over 1 minus tan h 1 plus tan upon 1 minus tan h into 1 upon h. LCM, LCM denominator is equal to upon 1, this upon 1, LCM of is equal to 1. So 1 minus 10, 1 minus 10 z, 1 cancel, is equal to minus 2 10 h upon 1 minus 10 h, 1 limit h is to 0. Now this is equal to, if you write minus 2 constant outside, limit this is equal to 10 h upon h, limit h is 0, this will become 1, and limit of the product is product limit of quotient limits using algebra limits is equal to limit of 1 is 1, limit is equal to minus limit of x is 0, 10 x is equal to 0. Minus 2 into 1 into 1 minus 1 upon 0 is equal to minus 2. Evaluate the limit h is 0 of 1 plus 2x is power x plus 5 upon x. Now we want to convert in this form. You know how which formula we have to use. So we know limit x is 0 of 1 plus x is 1 upon x is equal to b. So we will convert this form. So we arrange the terms. 1 plus 2x is power, separate them, upon x is 1 plus 5 upon x. So base is same, we can separate them. 1 plus 2x is equal to 1 into 1 plus 2x is equal to 5 by x. 5x, so limit x is limit of product limit of product limit of this is equal to x is 0, 0, polynomial function is equal to 1, and limit of this is equal to limit of x is 0 of 1 plus 2x is power 5 multiplied 2 divided by 2 to make them some cost same. 1 plus x plus 1 upon x. So this can also written as power is to m, this to n is equal to a to mn, reverse order. And this is limit x is 0 of 1 plus 2x is 1 plus 2x limit x is equal to 10. So this is equal to e. So this become, so as x is 0, to x also to 0, as x is 0, to x is 0, it's a very small number, finite number, very small number, very small number will remain very small. Therefore, this is equal to e is over 10. Now evaluate the limit. Evaluate the limit x approaches to 1 from negative of e to power minus x, so minus e to power minus 1 upon x minus 1. So make substitution here. Put x is equal to 1 minus h, as x is 1 from negative, h is equal to 0 positive always. So make this replacing the limit, change the limit from x to h, which is 0, e is power minus 1 plus h, minus equal 1 upon 1 minus h minus 1. Now cancel. So we are left with e is power minus separate, e is minus 1 common, limit h is 0 of e is power minus 1, e is power minus 1. E is power h minus 1 upon minus h. Multiply to the numerator minus and plus. This will go to the numerator, minus 1 is equal to minus 1. Limit h 0 of e is power h minus 1 upon h. E is power h minus is equal to log of e. Log of e to the base is equal to 1. So is equal to 1. So minus e is power minus 1 is the answer. If limit x is 0 of e is to h, minus a upon h will be log of a to the base e. E is log of e to the base e. If base is not written, base is e, this value is equal to 1. Now we will limit x approaches to 1 of log of x upon 1 minus x. Now again change the limit, plus limit is not written, you can plus one side limit plus limit or minus limit. Put x equal to 1 plus h, as x is to 1 positive, h equal to 0 from positive always. So change the limit from x to h. So is equal to exactly 1 plus h. Limit h is 0 of log of 1 plus h upon 1 plus h minus 1. 1 cancel upon h. Limit x is 0, h is 0 of 1 upon h into log of 1 plus h. So now again we're converting this into 1 upon h. We take the power log of n log of n is equal to log of n is to n. So this will become 1 upon h will go to the power and will become limit h is 0 of log of 1 plus h is equal to 1 upon h. Now limit can go inside. Log of limit n equals 0 of 1 plus 1 plus h is 1 upon h is equal to log of e to the base is equal to 1. Log of e to the base is equal to e and base is here e, or is equal to 1 is the answer. Evaluate the limit a is for x minus b to x upon sine of x, limit x is 0. Now we'll use the formula. A is for x, b is for x. A is for x minus 1 upon x, limit x is 0 of is equal to log a. B is for x minus 1 upon x is equal to log of b. B is for x, so we'll convert. We add and subtract, we'll make absolute so that this formula can be used. Add plus minus 1 here, plus 1 here. So numerator will be the same, they cancel out, but they will affect the result. So now divide numerator and divided by x, numerator divided by x. So this will x, and divided by x will go to numerator, a upon b upon c upon d. A is for x minus 1 upon x minus b is for x minus 1 upon x into the numerator x upon sin x, or we can make it equal to 1 upon sin x upon x. 1 upon sin x upon x. So now limit summative limit product limits using the limit of limits. So limit of this is equal to is 0 of a is for x minus 1 upon log of a, limit x minus limit x is 0 of b is for x minus 1 upon x is log of b, and limit of this is equal to 1 is equal to log of a minus log of b equal to log of b. Limit x is 0 of e is for sin x minus 1 upon x is equal to limit x is 0 of e raised to power sin x minus 1 upon sin x into what is denoted sin x by to make this same. So e for x and 1 upon x. So we multiply sin x. So now limit the product values. Limit x is 0 of this for sin x minus 1 upon sin x into limit x is 0 of sin x upon x is equal to 1. So as x is 0, sin x is equal to 0. So we can write here is equal to limit sin x is 0 of e sin x is to sin x minus 1 upon sin x. This will become log. This will become log of e. Log of e 1 is equal to log of e is equal to 1. So evaluate the limit x is 0 of e square x minus e square minus x upon sin x. Again we convert in the formula e square x minus 1 upon x, limit x is 0 is equal to log of e to the base is equal to 1. So we convert this, we convert them into formula by dividing by x. So is equal to 0 of e square x minus e square minus upon x into log of 1 upon limit x is 0 of sin x upon x. So is equal to 1. So adding 1, subtracting 1, adding 1, separating the terms, and converting into e square x minus 1 upon x is for x minus 1 upon x minus limit of is equal to limit x equals 0 of e square x minus 1 upon x is equal to log of e to the base e is equal to limit x is 0 is equal to uh, limit x is 0 of e square x minus x upon minus x is equal to is also equal to x equals 0 minus x also equals 0. So this is log of e 1 plus 1 is equal to, so we can answer. Thank you very much.